it's the periodic table time. So this is the periodic table, right? Remember, it's designed for chemistry. Okay, a physics periodic table would be a list from 1 to about 100. Remember, the atomic number is what we're interested in. Effectively, the atomic number tells us what element it is. So if it has 6 protons, it's got an atomic number of 6, it is carbon, no matter what. There are different isotopes of carbon, carbon 12, carbon 13, carbon 14, but it's carbon. So effectively, the periodic table, as we look at it here, and this is a nice one in that it only has the atomic numbers, right? Okay, starts at number 1, 2, and keeps going up as far as 56, barium. It continues here as 57. This is just put down here so that the table fits on the page. It goes to 71, 72 to 86, we've 87 and 88 here, 89 to 103, and 104 to 111, and there are a few more sets. Okay, there are a few more sets. Now, what we've looked at today is the fact that the strong nuclear force works at its best, okay, when an atom or a nucleus is around the size of iron. So iron is the most stable nucleus. Now, we're not talking about chemical stability, we're talking about the most stable nucleus. So iron is the magic one. Okay, iron is the most stable nucleus, and therefore iron, okay, is where we always want to be. Okay, if a nucleus is smaller than iron, everything up to here, right, it wants to be more like iron. Okay, so basically what can happen is smaller nuclei will join together to make a more stable nucleus, and there will be a release of energy, and that's our fusion. So they want to be like iron. If they're too small, they're inclined to join together, nuclear fusion, to make them more iron-like, as we have seen in the lesson earlier. Okay, if they're too large, okay, if they're too large, they get larger and larger. We've seen they become unstable again, and they want to be more iron-like again. They want to be like the iron, so they split, and that's fission. So the small nuclei want to be like iron, so they join together, fusion. The large nuclei want to be like iron, so they split into smaller parts, fission. Right, and that's it. That's it, basically, regarding the periodic table. Now, what is interesting with the periodic table is that we have naturally occurring nuclei up to 92. Okay, uranium 92. Some of them under 92 are very, very rare, but they're officially naturally occurring. Okay, beyond 92, we consider them not to be naturally occurring, but they can be made. They can be man-made, right? And it's the naming of these is quite interesting. Okay, so if we look along here, uranium is 92, named after the planet Uranus. 93, Neptunium, named after Neptune. 94, plutonium. We'll come back to plutonium and uranium, both involved in nuclear bombs and so on. Okay, named after Pluto. So plutonium is named after the planet Pluto, which is no longer a planet. There you go. Right. Okay, so there we have those. Right, and then we follow on. 95 is named after America. It's Americium, and there is americium in almost all of your houses. If you have a smoke detector, there is americium in the smoke detector. Even though it's naturally occurring, it is in the smoke detector, and we will come back to that. Right, what follows on then, CM, named after the most famous, well, one of the most famous physicists who happened to be female, okay, Marie Curie, and we will be dealing with Marie Curie, we've already met her. So curium. 97 is named after the university in California, so Berkeley University in California in America. So they're all named after American places. ES, our friend Einstein, Einsteinium. FM, Fermium, okay, Fermi, who we'll be dealing with, okay, fantastic Italian physicist. We'll come back to it. MD, Mendeleev, who made the table, okay, so there's an element named after Mendeleevium. 102, Nobel, named after Nobelium, named after Nobel, okay, who came up the prizes. 103, Lawrence, okay, the cyclotron, we'll see later, we'll be dealing with him. Ernst Lawrence, American guy. 104, Rutherford, we've already seen him. 105, 106, 107, 108, no real interest. 109 is Meitner, we will come to Meitner soon, another famous female physicist. And 111, we've already dealt with him, Röntgen. So the X-rays weren't named after him, but he has an element named him after now, which is pretty cool. Okay, so remember the periodic table, all we're interested in, it's a list of numbers from 1 to 100. If you're, for example, if you're number 3, okay, it has atomic number 3, 3 protons, therefore it's lithium. Okay, the mass numbers, we deal with them regarding isotopes, separate thing. Okay, and what you're going to do is you're going to take out your periodic table and your maths tables, you're going to get page 26, and you're going to draw a circle, or sorry, you're going to get to element 26, iron, and you're going to draw a circle around it, because that's the important one. Okay, that's the important one. When you're back in room 4C, have a look at the periodic table in room 4C, Ireland is circled because it's a physics lab. Okay, it's a physics lab. I'm not allowed to do it here because this is not my wall. Okay, talk later. Bye bye.